everyone, in this video I'm going to walk you through how to plot experimental data in Microsoft Excel, create a linear regression line, and extract both the linear equation and the R-square values. We will apply this to a real chemistry context, testing how whether an unknown metal is an actual gold or a false gold based on its density. The data set associated with this section of our lab can be located under section 1 or section A of the Word document of our lab procedure. Instead of using density, which is the property used to identify an unknown object, we are going to have the data plotted in Excel, and the slope of the best fit line will represent the density of the metal, and by comparing the known density of the real gold and the false gold, we can decide whether this data set represents a real gold density or a false gold density. We know that density is calculated by dividing mass over volume, but we're not going to do the calculations today. Instead, we will have Excel plotting mass versus volume, and we will create a linear equation, and the slope of the equation will represent the density. So let's get started by highlighting the data associated with table 1 here. I'm gonna Control C to copy that, and I'm gonna access Excel on my OneDrive. I'm gonna create and upload new Excel worksheet. Let's name it Lab3 section A XY scatter plot. Okay, let's get started. Here you go. I'm gonna open the Microsoft Excel, and I'm gonna go to column A here and Control V so I can import my selected data. Here you go. You would notice that the column A represents the x-axis or the horizontal axis, which here represented by the volume in centimeter cube unit, and the y-axis or the vertical axis represented by the mass in grams. So let's go ahead and highlight these data, only the numbers, and then go to Insert tab on the ribbon here and look for charts and select the scatter plot, which are the scattered points here. You should now see that your data points plotted with volume representing the x-axis and the mass representing the y-axis. So let's add these axis title so it makes more sense to you. Let's add the horizontal axis title. I'm going to edit the horizontal axis title for volume, and the unit here is centimeter cubed. Here you go. And I'll do the same thing for the vertical axis. I will edit that for the mass in grams. There you go. And the chart title should represent what was given in y-axis versus what's given in the x-axis. So the y-axis here is mass, so that should be labeled mass versus volume. You can add of an unknown metal just to make it relevant to our tested experiment. Then we're gonna add more formatting to these points. So I'm gonna left click double click any point here to format. I'm gonna screw down this list and select trend line so I can have my points connected. Here you go. It's connected by a linear trend line. And if you screw down further until you see equation and value, make sure to get that selected. Now you have the equation displayed on the chart. And if you go just one more step down and select display R square, now we have both the linear equation and the R square displayed. So that was it for today. Here is the linear equation, and the linear equation will be something similar to the general linear equation of y equal mx plus b, where y here represented by the mass in grams, x was represented by the volume in centimeter cubed, and the m, which is the number by the x, is the best fit slope of the line, and this slope is actually the representation for the density. By checking the number of the density here, we can tell that it's equal 4.7913, which is closer to 4.8, which is the known density value for false gold. So by comparing the known density with the density from the slope of the linear equation, we can decide that the identity of the given metal in this experimental data set is actually a false gold. How about the R square? What is the R square? What's the significance of R square? The R square should be a value closer to 1.0. The closer R squared to 1.0 means your data are fit very well. And the lower the R squared value means your points are scattered or there is error in the data. So since our R squared here has a value very close to 1, that gives us more confidence that our slope and density calculations are reliable and accurate. That's it for this section of the lab. Thank you for watching. Be sure to try this on your own and see what you can find. Thank you. Goodbye.